Welcome, grade 11. I just want us to look quickly at another way of finding the equation of a line. We know about the form y equals mx plus c, but we can also make use of the gradient form to work out the equation of the straight line. So what we have here is a situation like this. So suppose you've got a line, and that line passes through one point that you know. And that point, let's call it x1, y1. So x1, y1 is that one point on the line, and you know that point. But the line passes through so many other points, and so we pick an arbitrary or a general point on the line, and we can call that one xy, right? It is on the Cartesian plane, so it must be passing through points of the form xy. So using these 2 points, you can work out the gradient of the line. So the gradient of the line will become m equals y2 minus y1. So in this case, it's y minus y1. And that is divided by x minus x1. Right, if you rearrange that equation, you should get y minus y1 is equal to m multiplied by x minus x1. So I'm just multiplying both sides by the common denominator x minus x1. So you end up with an equation like that. So we can actually use this to work out equations of lines. Let's look at this one example. We are given the line passes through 2 points, 0, 2 and 3, 4. Maybe call your point 0, 2 x1 and y1. Okay, call that one x1, y1. And your other point 3, 4, you can make that one your x2, y2. Right. We are looking for equation of the line, so we need to know definitely the gradient of the line. But we will be using the form y minus y1 is equal to m into x minus x1. So what is the gradient of this line? Right, so the gradient is y2 minus y1, which is 4 minus 2, divided by x2 minus x1, which is 3 minus 0, and that gives you 2/3. So the gradient of the line is 2/3. Now we will take that and take our x1, y1 and substitute into this equation. And so this is what we get. Y minus y1, in our example y1 is equal to 2, is equal to m, and we found m to be 2/3. X should be kept as it is. So it's x minus x1. In our example, x1 is equal to 0. Okay, so that is the equation, but you can simplify that. So this becomes y minus 2 is equal to 2/3 of x. So that is the equation. You can leave it like that, or you can follow the instructions in the question and simplify accordingly. In this case, one thing you can do is you can actually multiply by the denominator 3 just to get rid of the fractions, or you can move the minus 2 to the other side just to make y the subject. Otherwise, that is your answer there. So if you want, move the minus 2 to the other side, so then this becomes y equals 2/3 of x plus 2, which is a very good form. You can leave your answer like that. But again, if you want to multiply both sides by a 3, by that 3, you will get your left-hand side equal to 3y minus 6 is equal to 2x. This is what you get if you don't want fractions in your answer. All right, let's look at the second example here, guys. In this example, our given point is minus 4, 0. So this is your x1, y1. Right, and we want to use our form y minus y1 is equal to m into x minus x1. So we need to do that. So let's find m. Remember, the line that we are looking for is parallel to the line 2y plus 3x is equal to 10. So 2y plus 3x is equal to 10. We need to work out the gradient of that line. So the best thing is to rearrange the equation. So that you work out the coefficient of x. So if you divide both sides by 2, you'll get minus 3 over 2x plus 5. Okay, so this means the gradient of this line is minus 3 over 2. So m is minus 3 over 2. And we are going to use x1 as minus 4 and y1 as 0. So let's do that in that equation there. So we end up with y minus y1. y1 is 0. Is equal to m, which is minus 3 over 2, multiplied by x minus x1. X subtract x1. x1 is negative 4, so it's minus 4. Simplify that. The left-hand side is y. The right-hand side is minus 3 over 2 into x plus 4. You can remove the brackets and you'll get y equals minus 3 over 2 x minus 6. All right, so that's your answer there. You can simplify that further, like multiply everything by 2 if you don't like the fractions. But otherwise, that is your answer there. Right, the last example, our line still passes through minus 4 is 0. So x1 is still negative 4, and y1 is still equal to 0. Right, we now know the gradient of this line from the previous example. The gradient of this line, I want to call it m1. The gradient of this line is minus 3 over 2. I'm doing this because we are given here that the line we are looking for should be perpendicular to the given line. So if the gradient of the first line is minus 3 over 2, it means the gradient of the required line will be 2/3. Remember, when you multiply the gradients of perpendicular lines, you should get a negative 1. Okay, so there we are. We know the gradient, and we know x1, and we know y1. So we can just substitute into that. So we are using y minus y1 is equal to m brackets x minus x1. And that gives us y minus y1 is 0. M is 2/3 this time. X minus x1, so it's x subtract negative 4. Simplify that, you get y equals 2/3 of x plus 4. Right, you can remove those brackets, and that should give you y is equal to 2/3 of x plus 8 over 3. Okay, plus 8 over